Hi guys, just going to go over how to find the points of intersection for two functions graphically today. If you look at the do now, the first question and the second question are both reviews. Number 1 says to state the solution to the system of equations graph. Solution, if you remember, means a point of intersection. So if I look at those two lines, they intersect right here. And all points written in the form x comma y can be represented by points of intersection. So the point of intersection here is at 1, 5. Number 2 asks you how many solutions there are. Solutions, again, are what we just wrote, points of intersection. In the first graph, there are 2 points of intersection. You might be a little thrown off by this graph, but there is an arrow right there, so that line would go on infinitely in the direction of the arrow. The second graph has 4 points of intersection. So we've done that in the past. Today what you're going to do is listen along to the video, and we're going to find points of intersection using the calculator when factoring is not an option. Question 1 says to state the solutions to the graph state the solutions to the equation h of x equals k of x, rounding to the nearest hundredth. Well, h of x is given to you, and so is k of x. They basically want to know where 2/9 x cubed plus 8/9 x squared minus 16 over 13x plus 2 is equal to that absolute value. And there's no way for us to factor when we have a cubic and an absolute value. So what we need to do is rely on the calculator. I wrote the steps on the right for you. The first step says to plug the first equation into y equals. So go to your calculators and type that first equation in. Remember, to get a fraction, you can push alpha y equals. Do that now. I'm going to do it on the board while you do it at your seat. When you get to the second equation, step 2, plug the second equation into y2. There's an absolute value there. We haven't done those in a while. So first I'm going to push the negative sign, which is next to the decimal. To get the absolute value, there's a few different ways you can do it. You can push math, go over to number, and choice 1 is absolute value. Or you could use alpha window and absolute value as choice 1. So finish plugging in your two equations now. Okay, so what we want to do next is push graph. Step 3 says to press graph. So what I'm going to do is graph my function. There's the cubic function. You can see it's got odd end behavior, if you remember that. The ends go in opposite directions. O opposite, O odd. And there's my absolute value function. It's upside down because there was the negative in front. So step 4 says to sketch a picture of the graph. I'm lucky where I can just drag this over. You guys should sketch a little picture right now and just label your picture h of x and k of x so you know which graph is which. You don't have to put numbers or dashes or anything crazy like that. It's just a sketch, just so you can reference. Now, if you look at this picture, It's sort of like the do now. How many points of intersection are there? 1, 2, 3. I see 3 points of intersection. Unlike the do now, they're not at whole numbers or integer values. And one way I know that is because it tells me to round to the nearest hundredth. So let's label, this is our first point of intersection, our second point of intersection, and our third point of intersection. What I'm going to do is use step 5 to figure out what those points actually are and round those values to the nearest hundredth. So if we look at step 5, it gives us 3 steps on the calculator to find the point of intersection. We're going to push second, trace, and 5. Watch what I do, and then I'll give you a little time to do the second one on your own. Second, trace, 5. The reason I'm pushing 5 is because it says intersect, and I'm looking for an intersection. Now when I do that, you can see as I push the left arrow, that blinker is moving to the left. You only want to push the left and right arrows to find the point of intersection. So I'm going to push that left arrow all the way over until I think it's on the point of intersection. Clicked it a few too many times, so I got to bring it back. And to me, that looks like it's on the point of intersection. If you look at the bottom left, in writing, in black writing right now, it says first curve. That means I'm on the first graph, and the first graph I plugged in was the blue graph, h of x. When you're on the first curve, push enter. Then the directions change to second curve and are written in red because you're on the red graph now. Push enter again. That's just letting the calculator know that you are looking for the point of intersection for 2 graphs. The directions change to guess, so you click enter one more time, and now you can see your point of intersection. I'm just going to drag that onto the smartboard so we can talk about it for a second. The point of intersection for the first point, the one that we labeled number 1, is negative 5.17, comma 1.38. Okay, that's the first point of intersection. I rounded to the nearest hundredth. That was right here. We're going to do the second 2 now. So try and do it without me guiding you through it. I'm just going to do it on the board silently while you try it at your seats. You should have gotten up to this point. I pushed second trace 5 and the right arrow until I was at another point of intersection. There's my first curve at that intersection, my second curve is at that intersection, and now I want the calculator to guess for me. I'll bring this over onto the smartboard. Round to the nearest hundredth again. So the second point of intersection is negative 1.13, comma 4.21. Let's try our last one. Second, trace, 5. I've got to move to the right. Looking for that point of intersection one more time. First curve, I'm on it. Second curve, I'm on it. And let's guess. So my third point of intersection to the nearest hundredth is 1.75, comma 3.77. Those are my 3 answers. I could not have found them without factoring. A few things to keep in mind. If you click enter too many times here, after you find the point of intersection, it'll reset, so you'll have to do it again. If your calculator keeps just saying first curve, first curve, first curve, and doesn't change to second curve, that means your second curve is not graphed, or your cursor is not on it. You cannot do the first curve, second curve guess unless you push second trace 5. You can't just use your left and right arrows, so that's a key step. I'll do one more problem with you, and that'll be example 2. When g of x and h of x are graphed on the same set of axes, which coordinates best approximate their point of intersection? Okay, this could be on the regions. I think that questions like this are on the regions when they're multiple choice, so we've got our great multiple choice strategy now of using the calculator. Take a second to plug those two equations into y equals. So in y1, I'm going to use alpha y equals to type in 2 over x plus 2. And in y2, I thought this was a good equation to review how to put log in the calculator. I'm going to use the log next to the 7 because there's no base given, so I know it's 10. I can use that log. If there was a base for the log, I would have to do alpha window instead. But I'm okay just typing the log in as I see it, using the log button that's to the left of the 7. So step 1, put the first equation in y equals. Step 2, put the second equation in y equals, y1 and y2. And now I'm going to graph this. Put a light sketch on your paper, a quick little sketch, nothing major, and circle the point of intersection that you see. Unlike the last problem, there is only one point of intersection here. So if you remember, to find that point of intersection, we are going to do second trace, choice 5 for intersect. And we want to bring our blinker, using our left and right arrows, over to the point of intersection. First curve is my red curve. Second curve is my blue curve. Yours might have been done in the opposite order. I jumped up to the logarithmic function first, and now I'm going to guess. My point of intersection, rounded to the nearest tenth, because that's what the answer choices are, is given by negative 0.9, comma 1.9, which is choice 2. So you're going to be working through the rest of this packet, depending on what your teacher said you have to do for either classwork and or homework. And if you have questions on any of this, come see one of us after school to help you out. I'm also posting this video on Edmodo and YouTube for my classes, so I'm sure your teachers will share that with you as well if you want to re-watch it on your own time.